river floods, flash floods, when water becomes one of the deadliest forces on Earth. It can flood hundreds of square miles for weeks on end, or wash away entire communities in a matter of minutes. The men and women of NOAA's National Weather Service track the path of water's fury, because your life could depend on it. In an average year, about 100 U.S. citizens lose their lives to floods, and the extreme damage caused by floods costs taxpayers an average of $5 billion.
The magnitude of it and the devastation can go on for days and weeks and months.
It might surprise you to learn that more than half of all presidential natural disaster declarations are for flood damage, more than for tornadoes and even hurricanes.
When you go into areas after flooding and you talk to people, they say, I've never seen anything like this before in my life. I never imagined this could happen.
But that's what happens to the small town of Shadyside, Ohio, when it's blindsided by a devastating flash flood on June 14th, 1990. Record amounts of rainfall saturate the ground around Shadyside. The land becomes too wet to absorb another 4 inches of driving rain that drops in just over an hour. A 3-story wall of water decimates trees, roads, and houses as it barrels down the valley.
Probably the amazing things that we'd never seen before was the utter total destruction in one point, and just a few feet down the road, it didn't touch anything. But wherever the floodwaters hit, it was total destruction and loss of life.
The rushing water flips over trucks like toys and sweeps livestock out of barns and stables. And many people's loved ones perish in the flood. People like Robert Ramsey, who loses his wife.
I wanted to be the one to find my wife, but I didn't want to be the one to find her. Can you understand that?
Most tragic of all are the many children who die that day.
You know, you came down this road all your life and you knew all these people, and I'm a school teacher and I knew children that lived on this road, and some of them are unaccounted for.
I found one little boy laying right up here, about a 6, 7-year-old boy. There wasn't nothing I did it. Our first and foremost concern is for the pain and uncertainty that many in the community here feel.
I was the coordinator for the County Emergency Management Agency at that time, and we lost 26 of our citizens' lives. A very traumatic event for the families, the lost loved ones, and also for the people that responded and tried to respond and recover from it.
The people of Shadyside were the victims of a flash flood, a mass of rushing water that formed so quickly nobody knew what hit them.
It was one of these events where the water fell upstream of where most of the people were, and the people that ended up being flooded were not aware of the heavy rain that had occurred upstream, and they were not aware of anything going on until the flood wave actually hit them and actually took houses off foundations. So it was a very extreme event.
Flash floods are harder to predict than general river floods because from start to finish, a flash flood event can happen in less than an hour, enough time to cause utter devastation, but not much time to alert and evacuate those in harm's way. That's why flash floods are one of the worst severe weather-related killers in the United States.
I don't think you're ever totally prepared for this. And the only thing we try to do is to improve our capabilities.
The key to improving those capabilities is to understand how flash floods form. And NOAA, the National Oceanic and Atmospheric Administration, is leading the charge.
Flash floods are extremely challenging in terms of knowing exactly the area where the most significant rainfall is falling, and the conditions of the ground are very important to know.
Bob Davis is a lead forecaster at NOAA's National Weather Service Forecast Office in Pittsburgh. Events like the Shadyside flood inspired Bob to painstakingly map the region's 10,000 stream basins. That data, combined with real-time radar, provides highly detailed rainfall readings of the local watersheds.
Bob has actually redefined all our river basins down to a very, very small level. So because of his work, we can actually go in and monitor these very small river basins. And many times that's where the flash floods occur. That's where the fatalities occur. That's where the damage occurs on these very small basins.
Prior to this, all we had were the radar amounts of rainfall on a county map background, and we would not necessarily know which creeks were involved in receiving that heavy rain.
Bob's efforts became part of a new age of flood forecasting at NOAA, known as the Advanced Hydrologic Prediction Service, or AHAPS for short. Now forecasters can provide quicker and more accurate flash flood predictions by combining Doppler radar scans with data on stream conditions.
We'll try to put the warning out before we have actually enough rainfall to flood, because we want to give as much time for the emergency folks to react to the warning as we can.
Hi, State Warning Point. This is Pittsburgh Weather. Yeah, we just want to make sure you receive the flash flood warning for Belmont County.
1, 2, 3, gotcha.
And during storm events, we have a good line of communication opened up at all times with them, both on the phone and radio. Okay, we've got high levels of stream flow on all 5 basins, and probably very much more. We're going to be having some problems.
We look back 20 years ago into the mid-'80s. Our lead times then, and we didn't have the radars or the technology we have today, were only about a half hour. And last year our lead time was almost 68 minutes.
Had Pittsburgh's current forecasting system been available in 1990, chances are the extra lead time it provides would have helped lower the death toll in Shadyside.
We had no idea that kind of flooding was taking place. We didn't have this type of technology. We didn't have the resources. We didn't have the information. And with the work of Bob Davis, we now can hone in, actually focus on these areas down to a very small scale, and has made prediction and detection much, much better than it was, again, even 10 years ago.
NOAA's National Weather Service can pinpoint dangerous flash floods and provide earlier warnings than ever before. Coming up, a flash flood overturns a busload of school children. Can rescuers get them out in time? Find out next. It happens all too often.
Everything was going fine, and all of a sudden, we just started moving off the bridge.
Time and again, people try to drive through flooded roadways and end up at Mother Nature's mercy.
I see my whole life flash before my eyes. It was unbelievable.
Would you cross that water again?
Oh no, I didn't know it was that high at that moment.
Only about 1.5 feet of water moving at 6 to 10 miles an hour can make your car boat immediately.
That's one reason NOAA, the National Oceanic and Atmospheric Administration, has implemented a public awareness campaign called Turn Around, Don't Drown.
The primary focus of the Turn Around, Don't Drown program is to tell people to be careful when they come to water-covered roadways.
Don't try to go across that flooded stream. Turn around and find an alternative way to get where you want to go. And if you do that, you'll get there. Yeah, because if you do it the other way, the odds are against you.
We have more fatalities due to people driving their cars through water-covered roadways than any other type of flooding.
In the summer of 1987, tragedy strikes in Texas when a bus full of school children tries to cross a flooded road and is sideswiped by a 10-foot wall of water.
The bus wouldn't go no more and it started sinking. And the water started getting real high, and our youth pastor said, let's get out and try to get to the bank.
17-year-old Chris Ray is the first to be rescued, while many of his friends cling to trees for dear life as the water continues to rise.
How many are there of you? There's about 40. How many? 40 in the box?
For 5 desperate hours, rescuers pluck terrified students out of the raging water. But sometimes the current just moves too quickly. 10 of the 43 children from the bus are lost that day. It's a sobering reminder of the lethal force of a flash flood. But roads aren't perilous only during flash floods. During a river flood, runoff flows from basin to basin, swelling downstream rivers beyond their banks, and that can mean hundreds of miles of dangerously flooded roads. While a flash flood hits hard and fast, a river flood builds over periods of days or weeks and typically impacts a greater mass of land. And though a river flood may lack the abrupt drama of a flash flood, its impact can be just as damaging. When floodwaters invade a home, the results are usually devastating.
Dad, how did it get up here?
Like in 1993, when a river flood sweeps through the house of Stan Hurst, destroying everything inside. Now, Stan and his daughter Sheila must root through the aftermath and gather what little is left of their old life.
I'm going to high ground. I'm going to find a place in Missouri, on top of a hill. When the water comes the next time, I'm going to say, you people that didn't leave, I can't feel sorry for you. You had your warning.
I guess we had a little snow melt up in East Tennessee, so we had a little rise, slight rise in the rivers with that. A little bit here and there.
Dave Reed is the hydrologist in charge of NOAA's Lower Mississippi River Forecast Center in Slidell, Louisiana, one of 13 river forecast centers throughout the U.S.
Not only do we have problems with spring floods, winter and spring floods for heavy rainfall, we also have to contend with heavy rainfall from tropical systems through the hurricane season.
During the flood or hurricane season, things can get pretty dangerous for river barge operators who use the river as their highway, transporting over 472 million tons of cargo annually, including gasoline and nearly half the grain exported from the United States. To protect both cargo and lives year-round, NOAA puts out a comprehensive daily river forecast, a forecast that monitors and interprets more than 80 data components affecting river conditions. To amass such a broad range of data, NOAA relies on partner organizations, including the U.S. Geological Survey, that measures river flow with its system of river gauges.
We would not be able to do near as good a job without the data and support that we receive from the USGS.
And NOAA also receives vital data collected by more than 10,000 volunteers nationwide as part of NOAA's Cooperative Observer Program. These citizens record measurements of local snow and rainfall every day. Some use traditional rain gauges and phone in results, while others are being modernized with new digital rain gauges that send information more often and in near real time. As the data comes in, it is automatically processed by NOAA hydrologists. The effectiveness of today's river forecasts adds to the success of NOAA's Advanced Hydrologic Prediction Service.
I use the information all the time because I live on the bayou. I'm always concerned what the river's going to do after a heavy rain. And generally, it's good to follow these guys what they say because they're usually very accurate, and it helps us in our business.
We monitor the forecast by the National Weather Service pretty closely. We rely on that pretty heavily.
NOAA's forecast centers monitor river conditions around the clock, throughout our country, always ready to prepare us for the worst. Coming up, a powerful Pacific rainstorm pounds Northern California. Can the system of dams and reservoirs keep floodwaters at bay? Find out next. We all depend on nature to provide us with an abundant supply of fresh water, but receiving too much water can result in violent floods. And too little, devastating drought.
It's the worst I've ever seen. For this time of year, there's no grass, very little water.
That's why managing the nation's water supply is like walking a tightrope, and all of our lives hang in the balance.
Well, water management is basically two things. It's in one case, it's a matter of how do you manage water when you don't have enough of it, and then conversely, how do you manage water when you have too much of it?
A prime example of the challenge of water management is the state of California, the most populated state in the driest half of the country. Much of the state's precipitation occurs in northern and central California, where federal, state, and local agencies maintain a system of dams and reservoirs and regulate the amount of water released for irrigation, recreation, or drinking. Most of California's fresh water supply is collected during the winter and spring, when huge amounts of runoff from rain and snowmelt fill the reservoirs. Sometimes too much. That's the case in December 1996 and early January 97, when a series of storms dumps a huge amount of rain around California's Central Valley.
Warm rain hit the Sierras. It just melted this snowpack just big like this.
Runoff quickly fills the enormous Folsom Reservoir beyond its capacity, and local water managers have a major crisis on their hands.
The water in the dam, behind the dam, has risen to the point now where it can begin to come over the top of the dam. It is a classic water management problem that they're facing out here right now, kind of like the bulge through the snake, if you will.
To avoid potentially catastrophic flooding that could occur, water managers decide to make controlled releases of water from the Folsom Dam. But so much water has to be released that rivers rise, levees break, and widespread flooding is unavoidable.
I'm afraid it is as bad as it sounds.
That's what they're looking for. 2 people standing in the water there.
The dangerously rising floodwaters strand Mike and Marianne Otterino atop their completely submerged car. All night long, the frightened couple cling to one another for dear life. 12 hours later, daybreak brings hope, and rescue helicopters finally spot them, still alive. Frozen and disoriented, they're hoisted to safety by a Coast Guard rescue team. As bad as the flood was, without the controlled releases of a good water management system, the devastation would have been far worse. Helping water managers are the forecasts provided by NOAA's National Weather Service.
Anytime a major flood event occurs, all of the water management agencies and National Weather Service river forecast centers work around the clock to fulfill our mission of protection of lives and property.
Gauging how much water to release during the flood season is the trickiest part of water management. Release too much, and there may not be enough stored up for times of drought.
Floods tend to affect people who live along rivers, and droughts affect everyone.
The lack of water in this reservoir can have some serious consequences in terms of fire suppression abilities, in terms of domestic drinking water, let alone irrigation water for farmers.
From 1987 to 1992, Southern California suffered a severe drought when winter precipitation was at a dangerous low.
It's April 30th, 1992, the Phillips Ranch snow course. And in this meadow here, we should have about 3 feet of snow. Today it's 0. There is no snow. Meadow's dry.
The lack of runoff kept reservoirs dangerously low, affecting everything from hydroelectric power to everyday water consumption. But thanks in great part to the evolving forecast capabilities of NOAA's National Weather Service, water managers in California and throughout the nation are better equipped to keep our water supply both plentiful and under control.
We work hand in hand, and everybody does their part. The Weather Service does the forecasting, we do the operating, and it's been a very effective partnership.
Coming up, a massive flash flood causes one of the worst natural disasters in U.S. history. Stay tuned. Throughout our history, water's fury has provided example after example of the vital need for NOAA's National Weather Service. And perhaps no community demonstrates the progress NOAA has made more than the flood-stricken city of Johnstown, Pennsylvania, situated at the bottom of 650 miles of mountainous and rainy terrain, making it the draining point of massive amounts of water. One catastrophe that stands out even after a century is the flash flood that devastated Johnstown, Pennsylvania on May 31st, 1889.
Water had been rising behind the South Fork Dam all morning, and the dam was overtopped about noon. And about 10 minutes after 3, the South Fork Dam just pushed away this massive earthen structure. 20 million tons of water began an hour-long descent on Johnstown.
The wall of water rose to 40 feet high, barreled downhill at 40 miles an hour, and leveled everything in its path.
People had no idea what it was until it was actually on top of them. They thought it was the apocalypse, and it just annihilated the city.
More than 2,200 people died in that horrendous flash flood, making it the second deadliest natural disaster in U.S. history. Some bodies were even found as far away as Ohio. Only 1 in 3 could be identified. There had been no warning. We've come a long way since 1889. Today, the Advanced Hydrologic Prediction Service, or AHAPS, is bridging a proven history of forecasting excellence by NOAA's National Weather Service with new technologies of the 21st century. AHAPS is a state-of-the-art system that presents crucial river and flood information in a way that's easy for the public to understand.
The whole purpose of it is to give better information to emergency managers and the citizens so they know what actions to take if flooding is likely to occur.
So if you're just listening to your weather forecast and hearing about a river forecast or a flash flood warning over the radio or on the TV or even reading in the newspaper, you're benefiting from AHAPS.
AHAPS is a vital part of the National Weather Service's ongoing mission to protect lives and property. When fully implemented, it will provide over $700 million in additional economic benefits each year.
The employees, the men and women of the Weather Service, are really a unique group of people. They are very dedicated stewards of the environment and stewards of the safety of this country.